Oh, hi there. Thanks so much for showing up for your math learning. It's Tutor Grant. I'm going to go into this corner down here so that you can see a well-organized, I hope, solution for question 25. I was asked about question 25 in Math League, and I said, ain't no one got time for that right now. But I promised people a video. I don't love this question, but it's a very good algebra test. I would rate this question like a 7 out of 10. But in terms of algebra challenge, for our level, it's like an 8 or a 10. Like it's an extremely good challenge. So let's see how you would do it. First of all, we have to understand the situation. There are 4,200 samples of a new juice that either contain blueberry or do not. Student A reports blueberry correctly 90% of the time when it is correct and when it is there, and 88% of the time when it's not. Student B, on the other hand, over-reports blueberry. They're correct 98% of the time. They only miss 2% of the actual blueberry, but they think it's there 14% of the time when it's not. Okay? And we know that student B reports 315 times more than student A. Okay? At the end of the day, we're going to be interested in the amount of times student A, B, and C all reported at the same time, but I don't want to get into that quite yet. Okay, so, I just had an idea and I have to test it. No, I'm not going to test it. I'm just going to do it my way. But I think I just thought of a different way to do this problem. But this is the way I would recommend that you approach this problem. So first thing that we're going to need to do is figure out, hey, how many samples do contain blueberry? So we're going to start that with this this idea here. This one. That was unintentionally funny. Okay, so we don't know how many samples have blueberry in them, so we're going to let B equal the number of samples containing blueberry. Thus, there are 4,200 minus B samples don't have blueberry. Okay? And here's another thing we know. The number of times A reports blueberry plus 315 is equal to the number of times B reports blueberry. We're told B reports blueberry. We can see they report blueberry far more often, 315 times more often to be exact. Because of that piece of information, we can now solve for B with the proper equation. So let's go. 90% of the time, when blueberry is present, here's 90% as a decimal, the A says blueberry is there. But A also says blueberry is there 12% of the time when it's not. So 100 minus 88 is 12%. Okay, this one's going to be 14 in just a second. All right, so how often does that happen? Well, 4,200 minus B times, still plus 315, is equal to 0.98 times B plus 0.14 times 4,200 minus B. Okay, those are all of B's reports, and these two things are equal, right? A plus 315 is equal to the number of times B's reports. Now we got some algebra that we can simplify. So I'm just going to do that off camera with a calculator, but I recommend that you use a calculator for this because calculator was allowed on this test. Okay, and done. So we get this line next. So I've just distributed that in, got 504, distributed that in, got this, and now we're going to collect like terms. So 0.9b minus 0.12b gives me 0.78b, and this plus that gives me plus 819 is equal to this minus that gives me 0.84b plus 588. Okay, so now we go ahead and do some inverse operations. we're going to take this away from here to get B all on one side of the equation. Okay, and we're going to take this away, 588, from this. 588 both sides, and then we get the next line, which is 231 is equal to 0.06 b, and we divide both sides by 0.06, and we find that's oh, what is that off the top of your head? I've done this on a calculator before, but let's just make sure I'm right. 231 divided by 0.06 is equal to 3850 equals blueberry. Okay, so now we know how many blueberry samples there are containing. And so this is the number of blueberry samples. And by extension, 4200 minus 3850 equals 350. This is the number that don't have it. Now we can go ahead and build another equation that is the total amount of reports from A, B, and C. So let's build that. Okay, so we want to know like A's reports plus B's reports plus C's reports. All right, well, A is going to be reporting correctly. Yeah, my mistake was so silly. Okay, A is going to be reporting correctly 0.9 out of 3850, but they also report incorrectly 12% of the time, and that's in 350 cases. B reports correctly 0.98 when it is present. So this is the number of times when it is present, and incorrectly over-reports 14% of the time when it's not there. Okay. C, on the other hand, correctly reports 2m% of the time. So that's 2m on 100. It's an m multiplied by 3850 plus 4m% of the time they are correct here. So that means 100 minus 4m% of the time they are wrong. And they actually report it there. All right? Let's simplify that as a function of this number m. Okay, so I'm going to do that on a calculator for sure, and I'll get you back after you've done the same. Okay, so we've gotten that simplified with the calculator. So let's take a look. Here we go. So just did the multiplications and collected some like terms, and I just wanted to break down a little bit. This one here, 2m divided by 100 that's 2m as a percent, multiplied by the number of times that blueberry is present, gives us 77m. And then this one here, this is 100% minus 4m. So this is the times that they incorrectly report blueberry. So we have to factor that into C's reports. So that's going to be 350 minus 4 times that divided by 100 is 14. Okay, so in other words, 350 divided by 25. So now we can simplify this even further, but we also know that this is greater than or equal to 8,000 is, well, what? Well, 7, 6, 8, 9, that's this plus this, plus 63m. And that has to be less than or equal to 9,000. We're finally just about there. All right, we want all the values of m that will make this equation true and make the number in the middle divisible by 5. Okay, and where did I get that? We're told that it's between the total number of reports, which is this expression here, right? which we algebraify in that way down there, or find the arithmetic for it. And then we have simplified it as much as we can. We can now do this cool thing where we subtract 7, 6, 8, 9 from all of these numbers. I don't know what I wrote down, 6, 8, 9, and then minus 7, 6, 8, 9. And that will give us this little inequality here. It's the same as working with equations and inequalities, unless you're going to multiply or divide by -1, in which case the direction of the inequality flips, but that doesn't apply here. We don't need to think about that. So this is 311 is less than or equal to 63m, which is less than or equal to, well, that would be 1311. So let's find all the values for m that make this true, all of them, ignoring the fact that we want divisible by 3. Okay, so 311 divided by 63, we definitely need 5 copies of that. So if m equals 5, then we are above this lower threshold. And then if we divide over here, just like 1311 divided by 63, that gives us, we need at least 21 before we bust over there. So m could be 5 all the way to 20 to satisfy this inequality. Now we need to think about all of the values that would make that divisible by 5. In other words, give us a final digit of total number of reports that's either a 5 or a 0. And I can see that if I had 2 of these, it would work, but that's not between 5 and 20. Okay. I'm going to need this to be like multiplying something to have it end in a 6, because I'll never get it to end in a 1. Wait, no, that's not true. Yes, it could be. Yeah, so the 63 times something must be equal to something that ends in a 6 or a 1 for this to be here divisible by 5. So we have to end in a 5 or a 0 to be divisible by 5. So this thing must end in a 6 or 1. So what values will make that end in a 6? Well, let's just take a look at all of those, and then once we see the pattern there, we'll find which of those numbers lie between 5 and 20 inclusive. Okay, so 2 works, but that doesn't help very much. We could multiply 3 by, well, 3 to multiply 2, so 12. Okay, that works. And then, is anything else? And a 6? I really don't want to make a strange error here. I think that's it, right? We just need to multiply it by 2. 4 doesn't. 6 doesn't. 8 doesn't. So it's 2 or 12 are the only ones. Okay. What about ending it in a 1? Okay, and 12 is in the list of numbers that we can fit. It fits between 5 and 20. 22 is the next one, and it's bust. It's too big. Okay, so if we want 63 times something to end in a 1, that could be a 7, or that could be a 17 as far as I can tell. And those are the only numbers. So then we total these up. 17 plus 7 plus 12. These values will make it equal a multiple of 5 that's between 8,000 and 9,000. We could verify. Let's verify. We'll verify with a calculator. Okay, so we are interested in finding all the work on the page at once. All right, here we go. 7, 6, 8, 9 plus 2 times 63 equals 7815. Good, but it is not bigger than 8,000. So let's go minus 2 times 63 equals this, plus 12 times 63 equals, there we go, we're in between. We'll go 7, 6, 8, 9 plus 63 times 7 equals 8,130. We're in between. That's great. What if we add another 630? That's going to be giving us this one. And hey, we're in between. So we add all these up, not this though, and we get 36. And then we'd really hope that 36, oh my gosh, it's there, yay! It's there. So that's how you would answer this very challenging problem from the Gauss contest 2024. I say it wasn't very challenging, and that's not really fair, is it? It's a pretty challenging question, just to avoid making an error. This is my third crack at the video, and the first one was because I wasn't organized. The second one was because I had an error and I couldn't spot it in time. And then the third one is because here we are. So yeah, it's a challenging question. This is probably what, like a 20-minute video. So if you're still here, I salute you. And the code word is ostrich. Put the word ostrich in the comments and I give you big time thumbs up. Bye for now, everybody.